Hi everyone, today we're going to be continuing lesson 5.5, solving polynomial equations. We're going to kind of pick up where we left off last time in finding all of the real zeros of a polynomial function. So we want to find all the real zeros of this particular polynomial function. You can prove to yourself, or you can just trust me, that even though this has 4 terms, that whenever you try to do grouping, it's going to be another one of those grouping fails. And so take a minute to write this first problem and then come back here and we will go over it. All right, the first thing we want to do is find all of the possible zeros, P over Q. Remember, P is the constant. So in our case, P is that last number, the 24. And so we want to write the factors of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Q is the leading coefficient, LC, and it's going to be the 1, that's the implied 1 in front of the x to the third. So Q is equal to 1, and the factors of 1, well, that's just 1 and 1. That is going to make our life easier. We're not going to have to deal with any fractions in this case. So if I want to write P over Q, or every single possible P, all 8 of these, divided by Q, I'm just dividing by 1, and anything divided by 1 is just that thing. Remember also from last time that we need to account for both positive and negative possibilities. So I'm going to say positive and negative 1, 2, 3, 4, 6, 8, 12, and 24. Those are all of my possible zeros. Now, in order to find actual zeros, we have to test zeros using synthetic division. You can start with any one of these numbers. You have 16 choices. I choose to usually start with 1 and just kind of work my way through it. However, here's the catch. Whenever you start with 1, 1 doesn't work. And then negative 1 doesn't work. And 2 doesn't work. Pause the video for a second, take a look at this, and either write down all of this information to visually see that none of them work, or at a minimum, write yourself a note that says, when you test 1, negative 1, and 2, they don't work. Here's the next one that we're going to try. I'm going to try negative 2. And so I'm going to do the same thing that I've done. Remember that you would want to be checking to make sure that you don't need any of those zeros as placeholders. I didn't. I had every single term, 3, 2, 1, and 0. But I would want to check to be sure. And now, whenever I try negative 2, I'm going to have a 1 that multiplies to negative 2 and adds to negative 7, multiply to 14, add to 12, multiply to negative 24, and finally, after 4 tries, I have found a yes. I get a 0 as my remainder, and so let's go ahead and label this as constant x and x squared. We're now going to rewrite our polynomial as kind of a partially factored polynomial. I know that negative 2 is a solution, a root, a 0, an x-intercept, whatever you want to call it. In order to change backwards from a solution to a factor, I need to change the sign, because remember, the thing that we use as our k value is, it's an x minus k. So if I see a negative 2 as a k value, my factor is actually x plus 2. Let's rewrite the polynomial by recombining coefficients with their variables. So I'm going to have x squared minus 7x plus 12, and we know that we equal 0 because we're going to be solving eventually. X plus 2 is a linear factor, and we already talked about the fact that we cannot factor it any further, but we have 3 terms, including a x squared in our other polynomial. So let's check that one and see what we can do with it. Because it has 3 terms, I should be able to use quadratic form, and so I'm thinking of 2 numbers that multiply to be positive 12 and add to be negative 7, and that would be negative 4 and negative 3, because those 2 added together will give me negative 7, but multiplied will give me 12. Now I have 3 linear factors, and I can go ahead and solve those. So I'm going to solve each of these equations by setting the factors equal to 0 and then solving for x, just like we did last time. X plus 2 equals 0 gives me an x of -2. X minus 4 equals 0 gives me x equals 4. And finally, x equals 3. Now let's take a look at these solutions compared to what we thought we would come up with. We know that x minus 2 was a solution. We kind of knew that from the beginning as soon as we got that 0 remainder whenever we did the synthetic division with -2. 4 and 3, if we take a peek up here at possible zeros, well, both of those are included. Notice also, and this is kind of a preview of our next lesson, we had an x to the 3rd power. Our degree was 3, and we ended up with 3 solutions. That's always going to happen. That's part of the fundamental theorem of algebra that we'll learn about next time.